Let's solve this problem. They have given that logical address equal to 64 bits, page size equal to 1 MB, page table entry size equal to 4 bytes, and we need to compute all these values. Okay, fine. Now what they have given is logical address equal to 64 bits, right? So let me assume this is the logical address of our process, and it will have a total of 64 bits. Fine. They have given that, again I am assuming that it is a byte addressable system, right? As always, I am assuming that it is a byte addressable system. They have given that page size equal to 1 MB. I can write this as 2 power 20 bytes. 2 power 20 bytes. Now if page size equal to 2 power 20 bytes, and if it is a byte addressable system, then the page offset field will have 20 bits, right? Page offset field will have 20 bits. Now if this is 64 and if this is 20, then this will be 64 minus 20, which is nothing but 44 bits. Fine. Now what we need to compute is what is the total size of the page table 1, page table 2, page table 3, right? See, before computing that, see, in order to compute the total size of page table 1, see, by page table 1, I mean the innermost page table, which means the page table which we create for the page tables which will hold the pointer to our process, right, to our pages of process. Anyway, let's see this, it will be clear. Now before computing these things, first I need to compute how many pages our process is actually having, right? For that what I should be doing is, see, if logical address equal to 64 bits, then our process size, our logical address space is nothing but 2 power 64 bytes, right? And also they have given that page size equal to 2 power 20 bytes. Now the number of pages our process will have is nothing but logical address space divided by page size, right? We have already seen this formula, and logical address space is 2 power 64 bytes and page size is nothing but 2 power 20 bytes. Bytes and bytes will get cancelled. 2 power 64 divided by 2 power 20 is nothing but 2 power 44, and it is number of pages, so I am writing it as 2 power 44 pages. Okay, this is the total number of pages our process or our process is actually having. Fine. Now we have computed the number of pages. Fine. So I am writing all the 2 power 44 pages over here, right? This is page number 0, this is page number 1, this is page number 2, and so on. It will keep on going till 2 power 44 minus 1, right? This is page number 0, this is page number 0, this is page number 1, and so on. This is page number 2 power 44 minus 1, because starting from 0 I need 2 power 44 pages, and so I am going from 0 till 2 power 44 minus 1. Fine. So I have created the 2 power 44 pages. Now if there are 2 power 44 pages in our process, then how many entries will this page table have, right? This is what I am going to say this as innermost page table, right? See, I am creating a page table for this process, right? This is the page table which I am going to create for this process. This is what we mean by innermost page table. Now in case if I create even more pages, then the page table which I created at this level is what we mean by outermost page table, right? See, we have various levels of page tables, right? The page table which I create as pointers to our process is what we mean by an innermost page table. Fine. Now how many entries will our innermost page table have? That really depends on how many pages our process has, right? Our process has 2 power 44 pages, data pages, right? In case if I have 2 power 44 pages, our process has 2 power 44 pages, I will have a total of 2 power 44 entries. Fine. I need to accommodate a total of 2 power 44 entries in this level of page table. Now how many pages do I need in order to occupy this page table? That is the question, right? See, that really depends on how many entries can be accommodated in a single page, right? Let's compute that. Number of page table entries in a single page. The formula for this is page size divided by page table entry size, right? Page size divided by page table entry size. Now they have given that page size equal to 2 power 20 bytes and page table entry size is nothing but 4 bytes. I can write it as 2 square bytes. Fine. 2 power 20 divided by 2 power 2 is nothing but 2 power 18. Bytes and bytes are getting cancelled. So 2 power 18 entries. So single page of our process can hold 2 power 18 entries, right? 0, 1 and so on. It can go till 2 power 18 minus 1. So I can maintain a total of 2 power 18 entries in a single page of our process. But actually, we want a total of 2 power 44 entries, right, to be maintained in this level of page table. So single page is not good enough in order to accommodate all the page table entries. So I might have to go for some more pages. Fine. So how many pages do I need to create? See, the next page will also have 2 power 18 entries. Fine. It will also have 2 power 18 entries. Fine. Now how many pages will this level have? Right? This level of page table. Actually, see, that really depends on, we have a total of 2 power 44 entries. Fine. 2 power 44 entries divided by 2 power 18 entries, 2 power 18 entries per page, right? 2 power 18 entries per page, which means 2 power 18 entries I can maintain in a single page. Now, entries and entries will get cancelled. This by pages, in case if I take it to the numerator, it will become pages, right? So, the answer for this is 2 power 44 divided by 2 power 80 is nothing but 2 power 26 pages. What does it mean? See, I need to accommodate a total of 2 power 44 entries, and if a single page can hold 2 power 18 entries, now in order to accommodate all the 2 power 44 entries, I need a total of 2 power 26 pages, right? That is what that is what we actually mean. So this level of page table has exactly 2 power 26 pages, right? We have a total of 2 power 26 pages over here. Fine. Now this is what I am going to name it as page table 1. Okay, this is what I am going to name as page table 1. It is not a rule, it is just a this is what I am following. Okay, in case if you want, you can name the outermost page table as page table 1, right? But I am naming the innermost page table as page table 1, and the next level of page table, in case if I create, I am going to name them as page table 2. Fine. That is not important. Now the question is, what is the total size of this page table? What is the total size of this page table? See, we have a total of 2 power 26 pages, right? And every page's total size is nothing but 2 power 20 bytes, right? Size of a single page is 2 power 20 bytes. So 2 power 26 into 2 power 20 bytes, which is nothing but 2 power 46. So I'm going to erase this line because it might disturb you. Fine. 2 power 46 bytes. See, 2 power 26 pages we have, and we are going to accommodate the complete page, right? In case if I place the page table entries, the complete page will get occupied, and so I'm going to take the page size, right? 2 power 20 bytes. In case if I would have had only few entries, which means in case if I'm not able to accommodate the complete page, then the answer will vary. We will see that later. As of now, we are going to accommodate the complete page, right? And so I have taken that 2 power 26 pages, where the size of a single page is nothing but 2 power 20 bytes. So 2 power 26 into 2 power 20 bytes, which is nothing but 2 power 46 bytes. This is the total size of this page table, this innermost page table. Fine. Now my question is, should we go for one more level of paging? right? One more level of page table. Should we create it or not? Definitely, because our page table is not accommodated in a single frame, right? I have multiple frames, and all these frames can go into some random all these pages can go into some random frames of RAM, and so this level of page table is not accommodated in contiguous addresses. So we cannot access it directly using simple addition. So I might have to create one more level of page table. Okay, fine. So we have a total of 2 power 26 pages, right? So in case if I have a total of 2 power 26 pages, then I need to maintain a total of 2 power 26 entries in this level of page table, right? The page table which I am going to create, because for every page we maintain a page table entry, right? We have a total of 2 power 26 pages, and so I need to maintain a total of 2 power 26 entries, right? Now how many pages do I need in this level? Can I accommodate in a single page all the entries? It is impossible, right? Because the number of page table entries I can maintain in a single page is 2 power 18, but I need a total of 2 power 26, and so a single page is not good enough in order to accommodate all the page table entries. So I might have to go for more number of pages. Fine. Now how many pages do I need? See, how many pages do I need over here in order to accommodate all the page table entries? We have a total of 2 power 26 entries. Fine. We have a total of 2 power 26 entries, and every page can hold a total of 2 power 18 entries, right? So 2 power 18 entries per page. Again, entries and entries will get cancelled. This per pages, in case if I take it to the numerator, it will go as pages, right? So 2 power 26 divided by 2 power 18 is nothing but 2 power 8. So we need a total of 2 power 8 pages in order to accommodate all the page table entries, right? In order to accommodate all the page table entries over here. Fine. So I need a total of 2 power 8 pages. So this is 0th page, this is first page, and I'm going to create till 2 power 8 minus 1 pages, right? 2 power 8 minus 1 pages. In case if you want, you can number it, and so on. See, I cannot actually indicate all the pages, right? 2 power 44 pages is way too much. It's a massive number. I cannot actually put all these things. I'm just putting the dots, right? We just understand it. Fine. We have a total of 2 power 8 pages. Now can I stop it here? I need to go. See, let's compute the size of this page table. Okay. Let's compute the size of this. We have calculated the size of the innermost page table, right? Now let's compute this level of page table, size of this level of page table. We have a total of 2 power 8 pages. Fine. We have a total of 2 power 8 pages, and all these 2 power 8 pages are completely accommodated with entries, right? So 2 power 8 pages for size of a single page is 2 power 20 bytes, right? So 2 power 8 into 2 power 20 is nothing but 2 power 28 bytes. See how I got this number. This is indicating the total number of pages, right? And this is indicating size of a single page. So number of pages into size of a single page is actually going to indicate the total size of this level of page table. Fine. So it is 2 power 28 bytes. Fine. Now can I stop it here, or I might have to go for one more level of page table?